Hey, and welcome back. So now we have a lot of basics in place. We have a foundation for our project. So we have our constants and include system and folder structure and everything's in place. We even have a system setup and the raster interrupts are in place. So now it's time to do something maybe a little more interesting. So today we're going to draw characters and also our tiles on the screen. So we're going to make routines for that, and which means that in the next episode we're going to build on what we do today to actually draw our levels. So now it's really starting to get interesting. So before we do that, we need to really understand how the Commodore 64 screen is set up. So let's take a look at that now. So here I have recreated the Commodore screen in Microsoft Excel. But I've also added something over here. Now we've seen this before, but now I have added something over here. At the top here it says 0400. So by now I'm sure you recognize that address. That's of course this little cell here in top left corner. Now I've continued down here. So what I've done here is that I've written the memory address for every starting cell here on the left. So for every starting cell here, this is the corresponding memory address. This one is this one and so on. So now I have a list here for every one of the starting cells here on the left. So okay, fine. Now let's also just confirm that we know that we have 25 rows down. By default we have 25 rows down. So I have counted from 0 and all the way up to 24 here. So 25 rows down. Then let's also remember that we have 40 columns across here. So I counted from 0 and all the way to 39 over here. So 25 rows, 40 columns across. That's our screen. So now is the question. Now we briefly touched on this a while back, but how can we place characters anywhere we want on our screen? Well, we talked about this thing with low byte, high byte and the 0 page, and how we could combine addresses to create whatever address we want. Well, that's what we have to do now. We need to make a system that's easy to use, and that's a system that doesn't require us to actually write in, oh, I want F8 here and I want to combine F8 with 35, for example, stuff like that. We can't have a system where we need to do that because our game needs to figure that out itself. This is something that needs to happen in the background. So how is that system going to work? Well, we are going to base our system on this. My little table over here, starting from these memory addresses. So imagine that this is my table now, that I have a table here called screen. And now let's imagine that we're in assembly language. So I have this table called screen. Now if you remember how we used tables, it's pretty simple. We used the X or Y register. Now let's imagine that we're using the X register right now. So what I could say right now, I could say load X, let's see, load X with, let's say 2, hashtag 2. So load X with 2, I could say. And then I could say, maybe I should write this over here. So if I say load X with 2, then I could say load A with screen comma x. That's how we use tables, right? We load x with an offset, then we load the label of the table, comma x. So in this case that was 2. So how would that work here? Well, if I say load a with screen comma x, we get 0, 1, 2. So now x is here, this address. Well, it doesn't really help us because we have this table with memory addresses like this, and they are full memory addresses like this. So if you remember what we had to do when we're dealing with stuff like this, again, this thing with splitting them up. So I can't have one table like this. That's gonna limit very much how I can use this. So what I'm gonna do right now, I'm going to split my screen table up into 2. So I'm gonna have a screen low and a screen high, which means that the high byte of every one of these addresses is going to be in one table. The low byte of every one of these addresses is going to be in another table. So my screen table here, in other words, is going to be split in 2. The low byte table and the high byte table. So what I've done, I've made a system that makes this really easy. So let's look at that now. So I have made a spreadsheet here in Excel that's going to create these tables for us automatically. And I'm gonna leave these Excel files on my website with a link below here. Now this is made with Microsoft Excel, so I even have some nice macros here with which allows me to use this button here. Now if you don't have Microsoft Excel, you have something like OpenOffice. I'm gonna leave a file that don't have these macros, but it's pretty much the same thing anyway. So you can use this if you have Excel or some other spreadsheet program. But anyway, what I have here now is a system that creates my table. I split it up into different columns like this. So if you remember this symbol pointing that way, that says this is the low byte. Whenever we use this in our assembly code, it says give me the low byte or something. So for example, if we take a look at this, if I say load LDA and I say something like this, load A with the hashtag and this symbol for the low byte. Load A with hashtag and a symbol for the low byte. That's going to give me the low byte here. So in that case, I'm actually saying load A with 0, 0, because that's the low byte here. Now let's also just confirm that why we are using this hashtag. Well, if I wasn't using this hashtag means that now I'm loading an actual number. If I removed that hashtag, what am I saying right now? Well, now I'm saying give me the low byte of the contents of this memory address. That really doesn't make much sense actually, because in my memory, let's say memory address 0400, there can be something like 1 in there. So in the top left corner, the memory address for the top left corner, there could be a 1 in there, so the screen code for A, for example. So if I did not use the hashtag, I would say give me the low byte of 1. So it doesn't really make much sense. So we need to use a hashtag to say, okay, so this is an actual number, and what's the number? Well, this is the actual number, but give me the low byte of that number. So that's the low byte. Hopefully that makes sense. So that's what I'm doing here, but I'm doing a lot of stuff in here. So if we take a look at the finished product here on the right, here I say, now remember we're creating a table now. So we have a lot of byte down like that. So I said dot byte. Then I use this symbol. Now I don't have this hashtag right now because now I'm just creating a table. So in our tables, table. Now in our table, we don't have to write a hashtag when we're writing values like this. So hopefully this isn't too confusing, but when we're making tables, we don't use hashtags like this. You don't have to. I think you can do it, but there's really no point. So tables, we just write like this. So what am I saying here? Okay, I'm saying byte. Let's look at the first entry in my table. So I said byte, low byte, and then I start, I do something here. In parentheses, first is a big parenthesis around this whole thing. But in here I say screen RAM. So 0400. 0400. Let's see if I can just copy this thing. Maybe it's easier to explain it here. So I say dot byte, screen RAM. Okay, so let me just do it like this. So screen RAM, that's 0400. 0 is 0400 for screen RAM. Alright, but here I say plus. Okay, plus screen width times 0. Alright, well, screen width, this is from my config file. And in my config file, I have specified that screen width is 40. So here, screen width times 0, that's of course going to be 0. So this very first one is just going to be the low byte of 400. Alright, so what about the next one? This one. Okay, let's look at that one. So the next one is this. It's the same thing, but now I say give me the low byte of screen RAM, so 0400 plus screen width times 1. Alright, screen width, that's 40 times 1, so that's 40. But 40 in hexadecimal, sorry, 40 in normal decimal. So 40 in normal decimal, that's 28 in hexadecimal. So I say 0400 plus this, which is 28 in hexadecimal, which means that this plus this, so this is going to be 0428, which if we look at my this one, yeah, that's correct, 0428, that's this one. So my system here seems to be working. When I go down, it's actually just logic really, because for every time you go down here, you're just adding 40 characters across like that. So when you get down here, you've added 40. So screen RAM plus 40, 40, 40, 40, and so on. So for every new row down, we add 40, or 28 in hexadecimal. So that's how I construct these tables. But as we see here, I'm saying the low byte, which means that now if we remove this low byte thing and see what I actually store in here, it would be, so this is the low byte, right? So here I actually storing that, and the low byte of this number would just be that. So that would be, this would be what my actual table looks like when it's done, when I sent it to the assembler, and the assembler has, you know, the assembler just is just going to translate all my symbols and parentheses and stuff like that. It's going to figure all of that out, this plus and multiplication sign, and in the end it's going to translate all that into numbers. So the top one here is just going to be this. The second one is just going to end up as this after it's been run through the assembler. So again, hopefully that makes sense. The point is that I'm constructing a table here, and it's just going to be, for this table, it's just going to be every low byte. It's going to be every low byte of this table. I could have written it this way as well, but just by doing it the other way that I have done here, now I can for example, in my so screen width, for example, we've briefly seen it before, but you can actually change the screen width to 38. So if I just changed that number to 38 in my config file, this table will pick that up. And screen RAM here, well, I've actually made this table so that I can change from screen RAM to screen color RAM, and as you see here, the table will change as well. So I just made it in Excel here to make it more flexible in a way, and also here I can change from low byte to high byte, and the table is automatically generated for me. So like I said, hopefully this makes sense. But this is just an easy way to make our tables. Let's see. So it's an easy way to make our screen tables. So we take this table, but we split it into a low byte variant and a high byte variant. All right. Well, so let's do that right now. Let's just create the heading now. I'm going to copy this heading, paste it in here, and I'm going to call this one Screen Tables. So if I go back to my table generator here, now I've set this for low byte of screen RAM, and as you can see here, my table is created. So with this Excel file with my macros, I can just click this copy screen table, and then I go back here to my file here, and I just paste it in like that. So here is the complete table, and it looks a little bit complicated when we see it like this, but when we start to study it, it's not really that complicated. Screen RAM plus screen width times whatever. So, and also, of course, this is the low byte table. Right, hopefully that makes sense. All right, so let's do the other one. So I'm going back here, and now I'm going to say, I'm just going to change it from the low byte symbol to the high byte symbol. And this name of the table changes as well. So I just click copy screen table, go back to Sublime, and I just paste it in here. So now I have a row low table and a row high table. I call it row because that's what this table keeps track of. It keeps track of what row this is. All right, so we have those two, but this is just the screen RAM. This is just placing characters on the screen. We need to do the same thing for the color RAM, because you remember screen RAM, that's in one place, 0400, color RAM, that's in another place, D1800. And those two have to match each other. So I need to go back to my generator, and I'm going to set it back to low byte, because now I'm going to go from screen RAM here to screen color RAM. So row color low, and my table is created, so I just click copy screen table. I'll go back to my Sublime, and I go to the bottom, and I just paste in my new table. So now I have 3 tables here. This new one, row color low, which is based on screen color RAM. So the same principle as the last one, but this time we're using screen color RAM. And this of course follows the same logic. So what I mean is that screen color RAM also follows this logic with 40 columns across, like that. So the screen color table would look the same, only we would be starting at D1800 instead of 0400. So the next one would be D1828, and so on. So it's the same thing, it's just a different starting address in memory. Alright, so now I created my row color low table. And there's just one more now. Screen color RAM, I need to have the high byte of that as well. So row color high now, I'm gonna copy that, go to Sublime and paste it in like that. So now I have 4 tables here. A table that keeps track of the screen RAM, the rows of screen RAM, low and high byte, and 2 tables that keep track of the same thing but in color RAM this time. Row color low and row color high. So 4 tables to keep track of that. So I'm gonna save those in, let's see, do I have, yeah, I have a tables folder. So I save this as screen tables, like that. Right. So now I have my screen tables file, but I have just made a file. I haven't connected it into the rest of my infrastructure here. So now after creating my screen tables file, I need to go to my includes folder, and I need to go to my tables file here. And oh, I already did it, but okay. So now I need to say import from the folder called tables a file called screentables.asm. So now I need to include this in my tables file, the file that keeps track of all my actual table files. Okay, hopefully all of this makes sense now. But the end result is that now, after writing this, I have access to all my 4 tables. So to make this work, now I need to add something else. Yeah, I've actually made this already, so let's just take a look at it. I made a file called 0page constants. So in my 0page constants now, actually let's also open up my memory map file. Finally, now we come back to this 0page address thing, because I said that you shouldn't take this with the other ones and paste it in here like we did with game code variables, all of the other things like that. So we're not going to be doing that with the 0page address like this. This is just to specify that I'm starting zero page at address 20. So why am I talking about that now? Well, if we go back to my zero page constants file, I make a few constants here, dot label cp row low. So the low byte of my row table. And I write cp just because it's zero page. What is that? Well, I say equals zero page address. So this one, 0020. I say that address plus 0. I write plus 0 just so it looks better. I could have done this as well, but I like to keep it clean, so I just write plus 0. It doesn't really matter. So that's my 0 page row low address. Then I have another one, cp row high, same thing, but this time plus 1. So that means that this address is actually going to be 20, 0 page address 20. This next one is going to be 0 page address 21, because I add 1 here. Next one is going to be 22, next one is going to be 23. So I take whatever my 0 page address is here, and I just add 1 when I go down like this. So that's going to fill up my 0 page addresses, if you can call it that. At least I'm addressing them correctly. Because remember, when we are using this system that we looked at by combining two addresses, the 0 page addresses needs to be right next to each other. So address 20 and address 21, they need to be right next to each other in order for us to use this combine technique. So by doing this, I can easily set up a system here. So here's my 0 page constant file. Now obviously I've included that in my includes here, 0 page constants, in my main constants file. Alright, so now what? Now we have 4 0 page variables. We have 4 of these low and high byte tables. What can we do now? Well, now comes the cool part. So it might seem a little complicated and a little, extra work to do all this stuff with our tables and stuff like that. But now we get the reward, because now we can do some clever coding. So before we code anything, let's just look at what I'm trying to do now. So I just want to do something simple. I'm going to start by saying I want to place a white A here. So let's see. That's what I want to do. Now I just want to place a white A right here. So this is 0, 1. So it's one row down, and it's 1, 2, 2 columns to the right. One row down, 2 columns to the right. And that's where I want to place a white A. Alright, so let's do that now. So by combining my screen tables now, the 2 tables for the row in ScreenRAM, so row low and row high, and the 2 tables for color RAM, row color low and row color high. Just by using those 4 tables and my 4 0 page addresses, combining all that is going to help us do exactly what we want to do right now. So I just say here, load X with 1, because I want it to go 1 row down. So that means that now I'm going to go 1 row down here on my table. And you remember that 1 row down, that's the first memory address here. That's what we have stored in our tables, only we have split them into two. So when I say load X, it's because I want this offset. Load X with 1, then I say load A with row low, comma X. So from that table, I'm gonna load what's in position 1 here. Then I need to store that in a 0 page address, because I'm gonna do this combined thing now. So I take this memory address 20, CP row low, and that's where I'm going to store whatever came from this memory, from this table. So that's the low byte of screen RAM. And I say load A with row high, comma X, and I have a 0 page address for CP row low, so memory address 21. Store that in CP row low. So now I've fetched the low byte and the high byte from two different tables. I've stored them, I stored them into two separate 0 page addresses. Those are right next to each other, 20 and 21. So I can combine them now. So now I've set up something that can create a memory in screen RAM for me. Now I need to do the same for color RAM. So the same principle, but only this time for color RAM. So load A with row color low, comma X, my table for color RAM. And I'm going to store that in, I have a 0 page address here for CP row color low. So that's memory address 22. All right. So I'm going to store that in there. Now I say load A with row color high, comma X. So we have to be very sure now not to change the value of X. It needs to be the same for all of these tables. So I load A with row color high, comma X, and I store that in this 0 page address. So 23. Store that in there. So now I have set up something that's going to create a screen RAM address for me, and I have set up something that's going to create a color RAM address for me, and those are going to match. I did not change the X in here, so the offset is the same on all of those. Okay, now what? Well, now I've set the right row like that. Now I said one row down, 2 columns to the right. So I'm going to use the Y register. I used the X register for rows like that. I'm going to use the Y register to go to the right. So choose the right column. 1 row down, 2 columns to the right. LDY with 2. So I'm just going to write a comment here that says row. And I write a column here, comment that says so column. Okay. Now finally, what did I want to put in there? Well, I wanted to put a white A at the position that I showed you. Okay, so I'm gonna say load A with 1, because that's the screen code for A. We know that, right? Okay, so where should I store that? Well, I'm going to store that in, so do you remember now this combining 0 page addresses? We need to use the low byte of those two addresses. Low byte address. So if I'm going to store this into screen RAM, then I need to use this CP row low. So the memory address 20 in this case. That's what I need to use in parentheses. So this would be the same as this. CP row low, but comma Y. That's how we did it when we combined these zero page addresses. We have this Y as an offset, and remember we can only use Y when we're doing this zero page combine thing. Alright, so now let's just see if this works. Oh, I have a problem. Okay, sorry about that. I was just confused. I was trying to run my code here in the game code file, and that doesn't work. We have to run press F7 from our main ASM file, because that's where our basic upstart 2 is. So just a little mistake on my part, but now let's try to run it. So I have an A up here. Yes, I do have an A up here, but I wanted a white A. So let me just finish this code now, because I placed the A at the right position, but I did not use I did not place did not place it in color RAM. So now I'm going to say load A with white. So actually, yeah, let's come back to that. STA. So where should I store this now? Well, it's the low byte. So CP row color low. That's the one we need to specify here in parentheses. So the memory address for the low byte. And again, comma Y. We need the same offset here. So now I should have a white A let's see, should have a white A, one row down, two columns to the right. So here somewhere I should have a white A here, and sure enough, there it is. There it is. Alright, well, this isn't too impressive. We have already placed characters up there. How about placing them further down on the screen? So for example, how about placing it down here? Now we couldn't do that when we were doing these loops and starting, we could only go to 255 characters like this. But now with this system, we should be able to place it maybe even the bottom right corner. So row 24, column 39. Let's quickly try that. So just by changing my row now to 24, changing my column to 39, that should be enough, right? Hopefully. Let's see. Yeah. So now we have this A here. So now basically we have a system where we can plot in whatever character we want, wherever we want, and what character we want, and what color we want. So by using this system now, we can place any character we want anywhere on the screen with any color we want. So that's cool. Now what I was going to say here just a minute ago is that actually in this case this wasn't necessary, because white is actually color code 1. So it was the same that we already had up here. Okay, anyway, doesn't matter. So this is cool. Now we have a system for plotting characters on the screen like that. But let's put this into some sort of system. So what I like to do now, once I have this in place, I like to add some new variables. So let's take a look at that. So I just made a new file here called tilevariables.asm, and I just plotted 4 variables in here: tile number, and all of this is just going to be 1 byte, right? These are normal variables. Tile number, tile row, tile col, this means column, so tile row, tile col, and tile color. 4 variables. Now, I mentioned this before, and let's just repeat it right now. What words you use, what terms, do something that makes sense to you. In my case, this tile thing is going to work for both my actual tiles and my characters. So like I said, it could be confusing, but I'm going to use this system for both characters and tiles. Okay. So now I've made this file. Now, since I made a new variables file, I have to remember, because of my system, I have to remember to go to includes, variables, and say import variables, tile variables, like that, to include my new variables file into my project. So I can't forget this one. Alright, so now I have some tile variables. Now what? Well, now we can make our first macro. Okay, I've started a new file here called tile macros. So we have briefly looked at macros before, but in order to define a macro in Kick Assembler, we need to write dot macro like that. I'm just going to call this macro DrawChar, draw character, and I'm going to give it a few arguments. The first argument is going to be what tile. What? No, I should write char here. This macro is only going to be used for drawing characters. I'm going to make a separate one for drawing actual tiles. So DrawChar. What char number do I want? What screen code? And what row? So I'm just going to write row, and then I'm going to write col, what column, and finally what color. So those are the 4 arguments for my DrawChar macro. And then I need to write these curly brackets like that. So these things, we need to handle them as numbers inside our macro here. So here I'm just going to say load A with hashtag char, because when this macro is used, numbers are going to be filled in here. Load A with char, store that in the variable that I just created, tile number. Store that in tile number. Then load A with row, store that in tile row. So another one of the variables that I just made. So I'm just going to do that for all of these. Load A with col, store that in tile col. Load A with color, store that in tile color, like that. So basically I'm just loading every one of these, storing them into separate variables like that. Alright, well, I just made a new macros file here. Once again, because of my involved system here, I have to remember to go to my macros file, includes macros, and I need to say import from the folder macros tile macros.asm. And also let's not forget that my macro here, when I write it like this, right now it's not taking up any space. I'm just defining it. If I never use this macro in my code, then nothing is going to take up space. The only time this is going to take up space is when I start using it in my actual assembly code. So just something to keep in mind. And that's the reason why I put the macros file itself up here together with the constants and all those, because none of those are going to take up space. So just a little reminder. Alright, well, this isn't going to do much. I'm just loading these, storing those into variables. So I'm gonna add something down here. Jump to subroutine, tile, DrawChar. Now that's a little problem right now. I don't have a tile library with a DrawChar subroutine. So I need to make that now. So in order to save some time, I've actually pre-written this library. But once again, since I'm adding a new file, this time a library file, I need to add it to my system. So I'm going to need to go to includes, libraries, and I need to say import libraries tile library.asm, just to include it into my system. Now hopefully if you're going to use this, you're gonna get used to you doing these sort of things very quickly, and the reward is that in the long run this is going to give you a lot more control. But you do need to add every single file that you create like this. Anyway, so my tile library, what's going on here? Well, here is my DrawChar subroutine, the one that I'm using here. So by the way, I talked about that you could run a subroutine from within a subroutine. You can of course run a subroutine within a macro as well. So just something to be aware of. Now you can't run a macro inside a macro, but you can run a subroutine within a macro. Alright, well anyway, here is my DrawChar subroutine. Now I start by transferring X to A, pushing that to the stack, transfer Y to A, pushing that to the stack, because I'm going to use both the X and Y register here in my subroutine called DrawChar. And not only that, but this subroutine is probably going to be used in some sort of other subroutine, probably some sort of loop of some kind. So that means that when I'm using those loops, I'm going to be using X and Y probably, and if I'm going to use this subroutine in a loop, then things are gonna get really messy with X and Y in my subroutine here. So I need to just make sure that the X and Y registers are preserved before I start doing anything. And when that's done, I restore the X and Y registers, so that, for example, if this subroutine was inside a loop, there would be no problem. It could be in a loop that uses X register, it could be a loop which uses Y registers, doesn't matter. This subroutine can be run anywhere right now. Okay, I just wanted to mention that. That's why I do this. So now we get to the actual subroutine. And what do we have here? Well, it's basically exactly the same thing that we did here with our little test code earlier. It's exactly the same thing that we did up here, but now we're not loading 24, 39 actual numbers like that. Now we are loading these variables that we made a little while ago. So I'm loading that tile row into X, and I'm loading tile col into Y, loading tile number into A here, and tile color into A. So if we look at the whole thing, you can see here in my macros, DrawChar macro, first I take all of these and I'm storing those into the different variables. Then after doing that, then I run the subroutine called DrawChar. And the DrawChar routine uses those variables. And in this case, it uses tile row to set up these tables with our 0-page addresses. Tile col to get the right column and tile color to get the right color. So this means that now I should be able to use this macro. So I'll just copy this, go back to my game code and paste it in here. So now I can say DrawChar 2, for example, screen code for B. What row? I don't know, maybe row number 2. What column? Okay, let's take 2 on that as well. Color, let's do yellow. Maybe it's confusing if we do this. So row 5, column 7, whatever. So now I'm gonna have a B, screen code 2, that's a B, at row 5, column 7. And this B is going to be yellow. Alright, so let's see if I get that right now by using this macro. So let's see here. A B, yeah, we have a yellow B, and I said 5 rows down. 0, 1, 2, 3, 4, 5. Yeah, it's hard to count, but it looks correct. And 0, 0, 1, 2, 3, 4, 5, 6. Yeah, so this seems to be perfectly correct. So this is really nice, right? We have a macro that we can just specify what character we want, what row, what column, what color. This is really handy. But I probably won't be using that too much, that macro, because the interesting part here is that this is a subroutine. This subroutine can be run, like I said, in a loop to draw some maybe even a background level, if you made a background level made up of characters instead of tiles. So you could draw some sort of loop system that would use this subroutine. But if we go down a little bit, go past my DrawChar subroutine, I have a new subroutine, and this one is super interesting. Now it's called DrawTile. So last time we just drew a character, this time we're drawing a tile. And once again, just like before, I'm starting by preserving the X and Y register this way. So I'm pushing X to the stack, I'm pushing Y to the stack, because I know that this subroutine is going to be used in a loop. So, but this time we're working with tiles, not just characters. Tiles are made up of 4 characters. So 2 at the top, 2 at the bottom. That's a tile that we have exported from CharPad. So tile numbers. So the first tile number is 0. The next tile number is 1. The one after that is 2, and so on. So that's no mystery. But let's take a look at another thing. The question is, how is my tile stored in this file that we export? So remember, from file, import, export, binary, we go to export tile set, and we export this entire thing right here. So that's going to be in one file. But how are these stored? How are these things stored in that file? Okay, let's take a look at this one. This one is simple. We're using one character. Character number, if you look down here, it's character 67. So this is character 67 all over the place. How about this one? Here we have 2 of these. So we have 2 characters 68. Here and here. Down here we have 2 characters 65. So this tile will be stored as 68, 68, 65, 65. So 4 numbers after each other like that. Starting here, here, then there, and there. So this whole file, tileset file, is just going to be a bunch of numbers. 4 numbers here, 4 numbers here, 4 numbers here, 4 numbers here. Now, obviously, they're not going to be split up or anything like that, because it doesn't work like that in the Commodore 64 memory. But we have to know about this. We have to know that in our tileset file, first of all, that's just a bunch of numbers. But we know in that file, every tile has 4 numbers. So starting from tile number 0, 1, 2, 3, 4. 4 numbers. So at the very start of that file, there are 4 numbers that make up tile 0. Then the next 4 numbers is this. 4 numbers that create tile 1. Then the next 4 numbers after that will create tile 2. Next 4 numbers after that will create tile 3, and so on. So the numbers are stored, so we have to know that for every 4 number, it's a new tile. Alright, so how do we do that? Well, let's not forget another thing. These tiles are 2 characters by 2 characters. So for what we just looked at a minute ago, that was drawing characters. That's easy. 1 character up, 1 character left, and just go by 1 in any direction. For tiles, we need to double that, because if you take a look at my map here, for every one of these, if I want to move this to the left, so let's do it like that. When I move that 1 tile to the left, that's actually moving it 2 characters to the left. So we have to have a system that's going to place, we can't have a tile here in the middle of these tiles, for example. That's not how my system works, at least. So the tiles are placed like this in a grid with 2 by 2 characters. So when I start my DrawTile subroutine, the very first thing that I do, I load my tile row, just like I did here with my DrawCharacter routine. But in that routine, I loaded it directly into X. What I do down here, I load A with tile row. But now, here's something new. Here's a new mnemonic that we haven't seen before. ASL, asymmetric shift left. What's that all about? Well, this is what we call bit shifting. Now, hopefully you can see my calculator here, but we know that we have zeros and ones in a byte like this. And we know that these are called bits. So bit shifting is when you move these bits, all of them, just move them to the left or to the right. We can't just move one at a time, we move everyone. So why on earth would we want to do that? Sounds so random, just moving once, just left and right. What's the point? Well, do you remember when I said that we can't do multiplication or division? And strictly speaking, we can't. But we can do it a little bit. We can multiply a little bit. So what's going to happen now? Now I have number 2 here in my byte. What's going to happen if I shift all of those bytes to the left? Now, since it's just the number 2, we just have 1 byte here. But what's going to happen if I shift to the left? So just by moving this little bit here to the left, I doubled the number here. So if I do it again, I double it again. If I move it again, double it again, and so on. So in one way we can do multiplication if we want to just double numbers like that. And if we do it another way, so if we push the bits to the right, it's the other way around. Now it's half. Half again, half again. So for every time I shift the bits to the right, it's going to be half. So what does that have to do with this? Well, let's take a look at tile row here, for example. Now I operate with tile row numbers now. So for example, this tile, this is placed at tile row 1. Now tile character number 1 would be just down here, but since tiles are 2 by 2, it needs to be here. This is tile row 1. So 0, if we think characters now, we have 2 characters down, 4 characters down, and so on. So we got 2 characters at a time here. So that's why I load A with tile row now, and asymmetric shift left, I shift the bits to the left, and then transfer that to X. So now they're doubled because my tile is 2 characters. That's why I need to double it first. So my tile row is going to be double of what character rows are. Hopefully that makes sense. So I do that first. I double my tile row so that I can, in my head, I can think, yeah, tile row 1 that's here, tile row 2 that's here. In my mind, I don't have to do this math. I just do that here instead. Anyway, and now I got my tile row. Now I do exactly the same thing that I did up here with when drawing our characters. I set a load from those tables and store those in 0-page variables, in the 0-page addresses for the screen RAM and the color RAM. And then I do the same thing for the tile column that I did with the row. Shift the bits to the left because tiles are 2 tiles wide, 2 tiles tall. ASL. Asymmetric shift left, shift the bits to the left. I do that first and transfer A to Y. Then I get to tile number. Then I do 2 of these. 2 of asymmetric shift left. So shift the bits 2 times. All the bits are shifted 2 times. And then I say transfer A to X. Why do I do it that way? Well, like we talked about just a minute ago, every one of these are 4 characters. So for every time I go up here in the tile number, that's 4, that's a plus 4. So 0, 4, 8, 12, 16, and so on. So if we once again look at my calculator here, and let's say tile number was 1 here. So load tile number 1. Alright, so I need to load tile number 1, but then I say shift the bits to the left twice. Once, twice. Now I get the number 4 here. So that's the number I transfer to X, because there are 4 characters here. Next one is going to be 4 here. So 1, 0, 1, 2, 3. Oops. 0, 1, 0, 1, 2, 3, 4. Okay, hopefully that makes sense. So then I transfer that to X, and now I load from the tileset address. So that's the actual file, the tileset file that we exported from CharPad. That's what I'm loading here, comma X. So with X and offset. Now I said that if this was tile number 1, then and I do this bit shift, then I end up with 4. So transfer A to X, that's 4. So let's say it was tile number 1, and I load from this file, comma X, which is 4 now. Tile number 1 is this. So that's going to work out great, because these are just characters, just numbers stored after each other. So I load that one, and now I basically do what I did before with the characters. Store that in screen RAM, and I've already set the Y up here. But now, because this my subroutine here, DrawTile, is much bigger than my draw character, because now I need to draw 4 characters. My tile is made up of 4 characters. I need to draw that. So, and all of this is going to be happening many times when I draw my level, because my level is made up of a lot of tiles like this. So this needs to happen fast. I need to load. Hopefully we can load our level so fast that the player won't even notice it. We don't want the player to sit and wait, looking at his watch, and wait for the level to load. So in order to speed this up just a little bit, instead of pushing to the stack again, I use this little trick. I store x to temp x, because here I say, here I loaded the character from my tile set. So remember, each tile is made up of characters, right? So now I load, for example, this character. So that's what I store in screen RAM. But now I'm not choosing colors. I want to choose the colors that I exported from CharPad. So I want my tile to look like this. So that means that I've exported my character set before, right? And then I also exported the character set attributes, so the color information. So what I'm doing here is I'm saying, first load the character from the first character of the tile. Then transfer that character number. So in this case, this is character number 67. Transfer 67 to X. Then I say, load A with character set attributes. So from my character set attributes file, comma X. Load that number from there. So what's the X? Well, the X is my character number, which was 67 here. So from my character, so my color file, comma X, that at position 67, give me that color code that was there. Now that would be red, multicolor red for this character. So now I'm gonna get the right color from my character set attributes file, and that's the color I store in my color RAM. Hopefully that makes sense. And that's the reason why I use this temp X, because here I'm actually corrupting X a little bit. I'm transferring the contents of this, what was in A here, to X, so that I can use the tile number to look up what color to use. And when I'm done with that, I need to go back, need to set the X back, because here is an increase X, increment X. Oops. Because now I've drawn this character, now I need to draw that character. So increase X and increment Y, because I'm not just going to get the next character here in the tile, but I also need to go one position further on the screen. And then I do the same thing over again. And by using this little method, I'm saving a little time for every one of these. So I'm doing that, but it's exactly the same thing. But now I'm drawing the next character in the tile. And then I say increment X again. So I still need the next character in my tile, but for the Y, here I just said increase Y, because this character is of course going to be placed right next to this first character on the screen when I'm drawing it here. But what about this next one? Well, the tile looks like this. It's not just a flat line like that. So now I need to go down a row and one column to the left. So what I do here, instead of doing what I did up here, which was increasing Y, I say transfer Y to A. So Y keeps track of where we are on the screen now. I'm transferring that to A because I need to use this add function that we can only use in the accumulator. So I say clear carry, add we carry screen width, the entire width of a screen -1. So when I place this on the screen, I need to do an entire length but -1, which is going to bring me right here. So if I was drawing the tile, we have placed the character here, here, and I go entire length of screen -1. It's going to be right here. So, because this is the third character in my tile. Alright, so I do that and then transfer A back to Y. So now I have the right position on the screen in my Y. And then I just do the same thing again. Continue loading from the tile set and color information, and yeah, and then the last one is just reading the last character from the tile. And now we can just do like we did before and increase Y, because this is right next to this one. So right here, we don't need to go a full screen length now because we already did that. So we are down here on the bottom right corner of the tile. Yeah, all right, so that's how I draw a tile. It's a little, I don't know if I should say it's complicated, but a little complex. And when I'm doing these sort of things, it's like you need to think about, do I have to make some super fast code now? And you know, how can I do this? And in this case, I used this technique to speed things up a little bit. So how about my macros now? Well, how about if we make a new macro, .macro, and I'm going to call this DrawTile, just so we can test this out. And I say tile here, row and col. Now notice I'm not writing color here, because like I said, when we're dealing with tiles, we don't want to specify colors in here. We just want to use, or at least I want to use, the tiles like they look here in CharPad. I want them to look like this in my game. So tile number, row and column. Then I basically do the same thing that I did up here. But now I don't need this color thing. And instead of char, I need to write tile. Yeah, and this, as you can see now, we're using the same variable for characters and tiles. Hopefully that's not too confusing. So I do the same thing, but now I need to run my DrawTile subroutine instead of DrawChar. DrawTile subroutine, that's in here. So now this is exciting. The question is, will this work now? Well, let's test it out. So I'm going to copy my macro here, go back to my main code, and let's try to draw 0, 1, 2, 3. Let's try to draw this tile to the screen. Tile number 3. Tile number 3 at what row? How about row number 1, column number 2? So now the question comes, will this work? Let's see. Now the colors will be a little bit wrong, but here we go. There we have our tile. Now the color is a little bit wrong because here the background color is black. So that's why the tile doesn't look exactly like this, because the black in here is the background color. And since the background color is set to purple here, it looks like this now. But you can definitely see that this is my tile from here. And in fact, it's really simple for us now because of our setup to go into the config file and change the background color from purple to black. And now our tile should look correct. Let's see. Yeah, I would say that's pretty much what I have here. So I would say that our setup is working right now, which is good because now we have a system to draw tiles, and we need that when we are going to draw our level like this. So that's what we're going to be doing next time. So hope this was enlightening, and I'll see you next time. Bye bye.